Today we are going to work on absolute value equations. Tomorrow we're going to work on absolute value inequality. So equations have an equal sign. Inequalities are going to have a greater than or less than sign. Yes, did I give you the wrong one? Look, everybody else look and make sure I just had these mixed up. You should have this, looks like this. All right. So let's talk about absolute value a little bit. The absolute value is the magnitude of a number without regard to its sign. So you should have learned about absolute values before. What is the absolute value of negative 40? See, Fernando, do you know it? It is positive 40. Okay, it is how far that number is away from 0, and distances are always positive. So negative 40 is 40 spots away from 0. So for absolute value of 230, for that, Caleb, what would the absolute value of 230 be? How far away from 0 is 230? It's just 230. One of my teachers, I can't remember which one, but one of my teachers I remember telling me that the absolute value bars are like the washing machine. What happens if you throw dirty clothes into the washing machine? They get clean, now they're clean, so they're positive, right? What happens if you throw clean clothes into the washing machine? They don't get dirty, right? They just come out still clean, right? So if you put a positive number into absolute value bars, like clean clothes, right, it just stays clean, right? It doesn't really change anything. So it just like washes away the negative sign, is what happens here. So you should get positives in both of these cases. Absolute value equations are just equations where you have the variable inside of absolute value bars. So let's start with some of the most simple absolute value equations we can possibly have, all right? So I've got absolute value of x equals 3. So anytime I'm solving an equation, I'm saying what numbers could this x possibly be? So Hector, what is one of the numbers that x could be right there? If I do the absolute value of 1, it's going to be equal to 3, though. So absolute value of this number has to give us 3. It's got to be 3 for that. So x could equal 3. But there is another number. There's more than one answer here. What else could I put in there? I could also put a negative 3. There. Those are 2 answers, right, that I could possibly have. Okay? So, in most of the scenarios that you see, absolute value bars are going to have 2 solutions. Okay? The second one, absolute value of x equals negative 5. What number could I plug in here? If I do the absolute value of 5, what do I get? I just get positive 5, right? Because it's the washing machine. It washes away the negatives. If I put a clean 5 in, I get a clean 5 out, right? Just positive 5. Is there anything I could plug in that would give me negative 5? No, because if you put anything into the washing machine, it comes out clean, right? It comes out without negative right here, unless you live in my house and somebody's put gum in their pockets or something. But right here, absolute value of x cannot equal negative 5, no matter what. So this one would be a no solution. Okay, so if you get an absolute value bar equal to a negative number, that's going to be no solution for that problem there. And then our last one, I've got absolute value of x equals 0. So, Cannon, what number could I use for my x there? What number, if I take the absolute value of it, is going to give me 0? 0. Are there two answers for that one? Can I have a positive 0 and a negative 0? I cannot, because there are 0 doesn't have a sign, right? Absolute value equations can have one solution, two solutions, or no solution at all. Okay? The most common, the one that you're going to see happen most of the time, is this two solutions. This is your most common. But you can bet that I'm going to occasionally sprinkle in a one solution or a no solution to make sure that you know what happens there as well. Okay, so let's work on some problems here. Okay, so solving absolute value equations is almost exactly like solving just regular equations, but there's going to be a little bit of a difference. You almost have to do it twice here. So let's look at example 6. Example 6 is not something that's going to show up on the Math 3 EOC. This is Math 1 material. It's a regular equation. It's like what you guys were doing last night, all right? So if I want to solve this right here, I like to put a line down my equal sign so my equal sign stays in the same spot. If you are bad at solving equations and your work is also super messy and you can't read it, perhaps you should try making yours look like mine, okay? If you get it right every time and you can halfway do it and you're not cheating, I'm okay with that too, right? Like if you can do a lot of this in your head. But if you're not getting it right, then your paper shouldn't look like a jumble of mess, right? You need to change that. So, Carson, what would I do first to solve that equation right there? I'm going to add that 7. Because you're trying to get that x right there by itself, you're going to start furthest away from it on that side, which is that 7. This is going to cancel out over here. I'll have a 2x, and then I'll get 18 over here. Okay. What would I do next, Carson? Okay, that 2 is right next to x, which means it's multiplied. To get rid of multiplication, you got to divide, so you're going to divide that 2. What do I get for the answer, Carson? 9. Okay, so it's a two-step equation, Math 1 stuff that we're doing here. Example 7 is not a lot different. But since I've got absolute value bars around my 2x minus 7, then 2x minus 7, if I get 2x minus 7 could equal 11. If I get 11 inside of those absolute value bars, I'll get 11 as the answer, right? Or, what else could 2x minus 7 equal that would also still give me 11? What do you think, Samara? It could be negative 11, right? Because if I get a negative 11 inside of those absolute value bars, it's going to wash away the negative, and I'll get a positive 11. So whenever we're doing absolute value equations, we have to do it twice, okay? So we're going to do it once with a positive, just as it is, and once where we change that answer to negative. And as we get to ones that are a little more complicated, I'm going to show you a couple more steps that sometimes have to be done, but right here, this is what we need to do. So we really already solved 2x minus 11 equals 9. Carson did that for us. He got 9. It's written there. I'm not going to rework that, okay? But I am going to have to rework this with the negative 11. It is not just going to give us the negative 9. I'm going to have to rework this one. So, Jamaja, what would I do first when I'm solving 2x minus 7 equals negative 11? Add that 7. Okay, so I've got 2x equals negative 11 plus 7. What's that going to give us, Jamaja? We got opposite. Nope. We got opposite signs right here. So whenever we have like a negative and a positive, we got to subtract the numbers, keep the sign of the bigger. Here is where, like, I would love for you to be doing that in your head. It's a good idea. But if you are not sure, type it in the calculator. Make sure you're getting it right. Okay? You can type it in Desmos here in a minute if you want to get the yellow calculators. Those are fine too. What would we need to do next, Jemijah? Divide by that 2. And so when we got negative 4 divided by 2, what will we get there? Negative 2. All right, so we're getting 2 answers for this. X equals 9, X equals negative 2. Okay, everybody good there? It's coming back, maybe remembering some. Yes?
Will it always work what I did? For that, I put a negative 2x and a negative 8 plus 7, and then it equals 11, and I still got 2.
For this problem, yes. Or for this type of problem, that would work. But when you get to the ones that are a little bit like bigger, it might be harder to do that. I don't know if I would probably go with making like that. Answer negative, I think you might get into some situations where it would be a little tougher for that. But essentially what you're doing if you do that, if you do negative 2x plus 7 equals 11, you're just kind of putting where we put this negative right here, like, let me just show you, like if I had, so what I have, 2x minus 7 equals negative 11. If I multiply both sides by negative 1, then that would give me negative 2x plus 7 equals positive 11, which is what you had. So it would work every time. There are some cases where it might be harder to do it that way. Does that make sense? So that could work. All right, Desmos trick time. Everybody look at your Desmos. If you don't have your computer up, you can look with your neighbor. All right. I don't even like doing this. I don't even like it. I feel like this is cheating, and I don't like it. But I also want us to do well on our final exam. Okay. So if you have an equation, you've probably seen this before. Absolute value of 2x minus 7 equals 11 was our original equation. Okay. Any equation that you do, Desmos should work for this. Okay. What you're going to do is right here, whatever is on the left side of the equal sign, right here, you're going to say f of x equals for that. So like over here in Desmos, I'm going to type in f of x equals absolute value bars. You can type ABS, although it doesn't change it to bars. Absolute value bars, if you click the functions thing, it's this little thing right here, 2x minus 7. So try that. Make sure you type that in. Make sure you know where the buttons are for that. Now, it will graph it if you don't put f of x equals. But for some things, it won't graph it if you put f of x equals. So just put it. I am always amazed at how lazy some kids are at typing things into Desmos where they don't put the y equals or the f of x equals. And most of the time it still works out, but there are cases where it doesn't, so just put it. Just put f of x equals. And then over here on the other side of the equal sign, we got just an 11. And you're going to say g of x equals. It really doesn't matter whether you're using f or g or h or k or whatever. Just use different letters for that. And I'm going to say g of x equals 11. Now let me show you. It will not graph this if you don't put g of x, right? So here is one of those cases. You've got to put it or it's not going to graph it. So just do it every time. It doesn't hurt anything. It's not that hard to type in, right? Okay, so what this is doing is it's graphing the equation of absolute value of x minus 7. It also graphs the equation of negative of 11, which is just a horizontal line, all right? So any equation that you do, if you do this, you are looking for where those two things are equal. Where on this graph are those two expressions going to be equal? What? Okay, it's going to be negative 2 and 9, which are our answers, which on this graph, how can I tell by just like looking at it on the graph? what is it? It's not x-intercepts, not y-intercepts. It's the intersection of the two graphs. So x-intercepts is where you cross the x-axis, y-intercepts is where you cross the y-axis. If you click on either one of the lines, you're looking for the points right here where the two graphs cross, right? And that happens at negative 211 and 911, but we're solving for x. So negative 2 and 9 are our answers for that. Okay? So you can do this on any one. Let's do the next one with Desmos just to prove it to you. Okay? So like, I just want to show you this on 8, because this is a trick. I don't like using it. This is not good. Like, you don't know how to do algebra very well if you have to do this every time. But sometimes we just do what we can, right? So I'm going to have, this side I'm going to say g of x equals. The other side, I'm going to say f of x equals. So, first line, f of x equals x over 3 plus 2, and then I'm going to say g of x equals 8. Okay? Do these cross? Not on my screen, or, well, yours may because you're probably not zoomed out as much as, or you might not be split screen, but all I got to do is zoom out a little bit or slide this over. Here they cross. Which one of those numbers is my answer? 18, because I'm solving for x, so I want the x coordinate, right? So this would be x equals 18. It works on any equation. Sometimes the graphs are crazy, and it's hard to find the answer because they're like if the answer is 7,000, it's kind of hard because you got to really zoom out and stuff. But it'll work, right? So any equation that you're given, you can use this to check it. Like right now, I'm going to require you to show some work on the homework because I want you to try it by hand. But type it in and check it to see if you're getting the right answers whenever you're doing that. Okay? So now that I've shown you the cheating way to do it, that is not really great math, let's go back and solve this one by hand to make sure we know how to do that. Okay? So for this one, you're trying to get that x right there by itself. Hunter, what would I do first on this one? Good. We're going to subtract that 2. So I still got the x over 3 left on this side. I've got 6 right here. Okay, now some students start to panic right here because it looks like a fraction. It is a fraction, but fractions are really just division, so that is x divided by 3. Joey, how do we reverse division? What's the inverse of division? Multiplying. So I'm just going to multiply by 3 right here and multiply by 3 on the other side. What's happening when you do that is 3 is on the top. Like this is like 3 over 1. 3 divided by 3 is just 1. Those cancel out, right? And so we get x equals, what's our answer for this one, Joey? 18. And then that matches what we got. I want you, to know all of your mental math really well. Whenever I was paying to get into the Surrey Central game last night, that poor fella, who I'm assuming is a teacher at Surrey Central High School, had his 8 multiplication tables right there and was having to look at them. And I was thinking, I hope not. If he's a math teacher, we're really in trouble. I have no idea. But he was checking it there. Maybe he's not a teacher. Maybe they use like outside people, because sometimes we used to have some people that would help like at football and stuff that weren't school employees. So I don't know. Maybe he's not a teacher. I don't know. I saw the multiplication tables there, so. But he got it right. It was fine. He got the right answer, so I'm all right. Okay, now let's look at number 9. Okay, number 9 we don't want to immediately turn it into two equations. This is absolute value, so we're going to have to eventually have two equations. But we don't want to immediately turn it into two equations. Let's make ourselves a note right here. Do not turn the problem into two equations until the absolute value bars are by themselves. Okay, so what that means right here is when I see this, the absolute value bars are just around the x plus 5. So it's just this part right here that's inside of the absolute value bars. That means I've got to get rid of anything that's on the outside of those absolute value bars before I switch this into two equations. Okay, so I need to get rid of this 2, I need to get rid of this 3 before I make it two equations, and then I will make it two equations. Okay, so if I'm trying to isolate that x plus 5 in the absolute value bars for that, let's see, Zoe, what would I do first? Okay, we're going to subtract that 2. So I've got absolute value of x plus 5 over 3 equals 6. And Zoe, what do I have to do after that? Times by 3. So I multiply by 3, which cancels this here, and I multiply by 3 over here. So absolute value of x plus 5 equals 18. So you guys see how that's the same as the other equation that we just solved that was like a Math 1 type problem? Now, absolute value bars are by themselves. They're the only thing on that left side of the equation. Now is when we write it as two equations. So I'm going to do, the first equation is exactly like it looks, except for I drop the absolute value bars. So x plus 5 is going to equal 18. And then the second equation, what's in the absolute value bars stays the same, x plus 5 equals, and then I'm going to change the sign of my answer. So instead of 18, I'm going to get negative 18. You have to do this. If you are doing your assignment and you're only getting one answer for every problem, you're forgetting to do this. Most of your problems are going to have two answers. Occasionally you'll just get one. Sometimes you'll get no solution, but most of them are going to have two answers. So I need to solve this. Sophie, what do I need to do to solve the first one? Subtract 5, very good. And so whenever I do 18 minus 5 there, I'll get 13 for one of my answers. And then Sophie, what do I got to do for the other one? Also subtract 5. And you'll find it's always like the same steps, you just get different numbers because this is negative over here. So negative 18 minus 5, they both have negatives. I add them together. I'll get 23, but since they're both negative, they keep that sign. So negative 23. So 13, negative 23. I don't like to do it, but I do like for you to know how to do it because I like to get good test scores on my Math 3 exam. So if I want to, I could have done it this way. F of x equals absolute value of x plus 5 over 3 plus 2. That's everything on the left side. G of x equals 8. I look for where they cross. It is right here, negative 23. Right here, positive 13. Okay, so you can use that to check your work. Okay, questions so far? All right. Okay. Oh, why did I wait till here to put these? I don't know why I waited till here to put the instructions, because it seems like that should have came earlier. But to summarize what we just did, the first thing you want to do is isolate the absolute value bars. An important note right here. You can never distribute into the absolute value bars. So like for 11 right here, don't do this because it's wrong, but let me just show you what I'm talking about there. A lot of kids see this 4 right here, and they're like, ooh, I'm going to distribute right there 20x minus 40. You cannot do that. Absolute value bars are different than parentheses. Parentheses, we could do that, but not absolute value bars. So don't do that. That would be wrong. Once you get the absolute value bars by themselves, you split it into 2 equations, one positive and one negative, and then solve your solution. That should say by substituting your answer into the original problem. Okay, let's do one more together. I'm gonna let you guys try 11 on your own here. So I'm gonna start off. Actually, I probably shouldn't have drawn that quite as long. I'm going to start off, are my absolute value bars by themselves yet over here? Are they the only thing on this side of the equal sign? They are not. I've got the stray -5 over here. So, Emma, what would I do to get rid of that? I'm sorry, -3. What would I do to get rid of that -3? I'm going to add that 3. Okay? So, I got absolute value of 2x plus 6 equals 16. Okay, are my absolute value bars by themselves now? Yep, I've got nothing on the outside except for the 16, which is on the other side of the equation. So now I need 2 equations. Let's see. Jose, what's the first equation going to be? Okay. All right, so what we do here is we're going to just write it exactly the same, except for we don't put absolute value bars. So our first equation right here is just 2x plus 6 equals 16. So like nothing changes except for you don't write the absolute value bars. In fact, a lot of kids don't split it up and they just keep on solving like the absolute value bars aren't there. You'll get one of the answers right if you do that correctly. Okay, the second equation. So Caden, what's the second equation going to be for this one? 2x plus 6 equals -16. So all we're doing there, one of them's exactly the same, one of them we make the 16 negative. All right, and then we've got these that we're going to solve. So Jose, for this first one, if I'm trying to get that x right there by itself, what would I do first? Very good. We're going to subtract that 6. Y'all are so good. 2x equals 10. All right, and then I got to get rid of that 2. What am I going to do with it? Divide. Very good. And what do I get for my answer, Jose? 5. All right, so there's one of my answers. Okay, I'm going to go do the same thing on the other one here, except for I've got a -16. So Caden, tell me how to solve that one. Caden, how do I solve that one? -6 on both sides. I'm going to get 2x equals, what's that give me, -16 minus 6? Same sign, add them together. -22, very good. Then what do I need to do? Divide by 2. Beautiful. What do I get for my final answer? -11. Great. Okay? Are we getting the idea? All right, try 11 on your own. Yes. Okay. Encourage it. I want you to be able to do that. Like if I put Desmos up here, I would have to put f of x is going to equal 4 absolute value bars, 5x minus 10 plus 23. That's everything on my left side. G of x is going to equal 3. And where do those cross? They don't cross at all, right? Let's see. Let me put the document camera on here. Zoe, can I borrow yours? Right there looks good and bad at the same time. It's right, but it's wrong. You didn't do anything wrong. Let's see if I fixed this the other day. Oh, yeah, I did. Okay. All right, so let's look at what Zoe did right here. Okay. Come on. Focus. Okay, there we go. All right. So Zoe here subtracted 23. Right? Is that the correct first step? Should be. She got a negative 20 right here. A lot of you were not sure what to do with this 4 right here. With that 4, you're going to divide by 4. You cannot distribute the 4, but it's whenever 4 is right next to those bars, it means it's multiplied. So you divide by 4. And she did leave one. She's kind of like, I'm going to add in one more step for you, Zoe. Because right here, you are getting absolute value of 5x minus 10 equals negative 5, right? She skipped straight to like writing them separately, which most of the time is fine. So if you have this, you'd have 5x minus 10 equals negative 5. It is exactly like you have, but without the absolute value bars. And you would write 5x minus 10 equals positive 5, exactly like it is, except for we changed the sign of our answer. Has she done anything wrong yet? Looks fine. Add 10. That gave her 5x equals 5. That's right. Divide by 5. You get 1. Seems valid, right? Then down here for her other equation, she added 10. Got 15. 5 plus 10 is 15. That's correct. She divided by 5. 3. Correct. Right? She's not messed up her algebra at all. Right here. The problem is you have to be very careful if you get one of these. And these will just barely be sprinkled in. You're not going to have a lot of these, but you will have some of these. Whenever, the key to knowing what this problem is right here in this line that she did not write down. Okay? I've got absolute value of 5x minus 10 equals negative 5. Can stuff inside of the absolute value equal a negative number? It cannot, right? Like, once I get the absolute value bars all together, it cannot equal a negative number because it's going into the washing machine. The washing machine washes away all the negatives. It cannot equal a negative. So right here, where you see that you've got that negative 5, at that point, that's when you should say no solution. Right there. Okay? It is hard to catch it, especially if you're doing most of these by hand, because you're just like in the groove. You're just doing it over and over like it looks right what Zoe has done here. But as soon as you get the absolute value bars all by themselves and it equals a negative number, that has to be no solution. That's another reason it's really good to check your answers on Desmos, because Zoe had done all of this and she called me over. She's like, there's a problem, right? Because this is not matching what I'm seeing in Desmos. So it's really good to check yourself in Desmos for that. That looks good. You guys see what's happening there? That one's true. And you got to really watch out for those. All right, let's finish up so we can do some work on our own here. Where do I need to click? I guess I just need to close that. Why is it not? There's where I want to go. Okay. So that one, there was no solution. Let's move on. Okay. I think I didn't teach them how to use Desmos until the end. Oh wait, no. But I've already shown you how to use Desmos. If you get absolute value of x plus 5 equals 3x minus 7, what's different about this question than the ones I've given you before? What? You got an x on both sides, right? The questions we were doing before just had a number right there. So we could make a positive number and a negative number. Technically, this is in Math 3 curriculum. We also only have so much time. Because of this, if you see one like this, use Desmos on it. I'm not going, you get Desmos on the exam, use Desmos on this one. So I want you guys to try Desmos on this one, on these two right here. Should have said look for the intersection of the two graphs. I didn't fill that in. And the x-coordinate is answer. Sorry. All right. Intersection. And the x-coordinate is your answer. Lots of us have got these here. So I'm going to do one of them on Desmos here. This first one, f of x equals x plus 5, and then 3x minus 7. You're looking for where they cross. You do want to make sure they don't cross at more than one point, but most of the time these only are at one. X coordinate is 6, so you should get 6 for that first one. I think most everybody done the second one. What were you guys getting? 1. Caden over here was kind of like guessing and checking it. That works if you have the right answer. So like 1's a pretty easy answer. So like if you're like, oh, 2 minus 3 would be negative, 2 times 1 minus 3, absolute value, that's absolute value of negative 1, it's just 1. Over here, if I do 3 times 1 minus 2, that's 3 minus 2, that's also 1, so 1 has to be the answer. That's fine, that works. It's going to be hard to guess and check if the answer is 7.2 or something like that, but you can try for that. All right, any questions? All right. So I've got a